Let's work on the problem 5.2.7. In this problem, we need to use superposition technique. In the superposition technique, we need to turn off all the independent voltage sources and the current sources. When you turn off the voltage source, we're going to make it to short circuit. When you turn off the current source, we're going to make it open circuit. So in this problem, we have one voltage source and then one current source. So let's turn off the current source first, make it to open circuit. Then it looks like this. And we're going to call this current I sub A1. So here's the open circuit, and we're going to just erase this portion so that we can clearly see what kind of circuit it is. So the first thing we need to do is identify any parallel and series resistors. And we know we have 12 and 6K. They are series, therefore it looks like this. Now 2K and 6K, and these are not parallel or series. When we have the current hit this node, it's gonna split into 1, 2, 3 different ways. However, when you compare going from here to this node, this is much faster and easier. This route, there's 18 kilo ohm resistance, so it's just a local way. However, going downward is the highway. So when we have a short circuit parallel to any resistor, that resistor, we can simply ignore that. Now we can redraw the circuit something like this. Now you might say,
hey Dr. Kim, what about this 3K? Is it the parallel to this short circuit?
well, we need to look at both hands of this 3K. So I have one hand holding 6K arm. Where is my second hand? This whole thing. So actually, this 3K and 6K, they are parallel. 3K with this short circuit is not parallel. So now let's combine 6K and 3K together. If we redraw the circuit, it looks like this. In 6K, we said parallel with the 3K. We multiply together the numerator, and then we add the denominator, that is 2K. Now, the current, actual current, this is the single loop, so higher potential to lower potential. So actual current, I is going to go in that direction, and then I equals to what? The total voltage, 6 over sum of these two resistors, 4K. So it is 3 over 2 milliamp. Now let's go back and take a look at the circuit here. So that is I, which is 3 over 2 milliamp. Then this 3 over 2 milliamp hits this 2K, and then that'll give us the voltage across this 2 kilo ohm resistor as 3 volts, right? V equals to IR, I equals 3 over 2 milli, and then R is 2K, K and milli cancel, 2 and 2, so now we have a 3 volts right there. And if we do KVL in this top loop, this entering the negative terminal of 6 volts plus 3, and then we're gonna call this guy as V1. So negative 6 plus 3 plus V1 equals to 0. Then the V1 is also 3 volts. That means the current going in that direction, I'm going to call it I sub 1. I sub 1 equals V over R, right? So 3 over 6K, that is 0.5 milliamp. So finally, we can calculate I sub A1 doing KCL at this node. KCL at node A, entering IA1 plus the top one, I coming down in here, so entering to that node, 3 over 2 milli equals leaving I sub 1, which is 1 over 2 milli. So I of A1 equals 1 over 2 milli minus 3 over 2 milli, that is negative 1 milliamp. Okay, now we need to turn off the voltage source. If we do, it looks like this. And then we're gonna call this as I sub A2.
Hey Dr. Kim, is this, again, short circuit?
No, because it's not parallel to anybody. If you look at the left or right hand I'm gonna say left, and I'm gonna say this is the right hand. I'm not sharing my left and right hands with any of the resistor in this circuit, so it's not. And as a matter of fact, this node is not no elements in this node. Therefore, this is one node. I'm gonna call it node A. And also there is a bottom node, and we're gonna call it node B. And this node B is actually also including this guy as well. So forget about I sub A2 for a moment. Let's analyze the circuit, and then we'll come back to this circuit diagram to identify what's the value of the current I sub A2. We have one more node right here, and we're gonna call it as a C. Now if we redraw the circuit, then we have A and C right there, and there is the current source. And then when we look at this 2 kilo ohm resistor, where is it? That is between A and B. So that 2K, we need to connect A to B. That is 2K right there. Now what about 6K? 6K is also node A to B. Done. And we have 3K right here. That's also node A to B. Done. And then now we have this 12K, which is B to C. Done. Now what about this 6K? B to C. Now we can clearly see that which two resistors are parallel, right? Let's combine this 6K and 3K together, and this 6K and 12K together. So when we combining 6K parallel to 12K, that is multiply them together over, add them together, that is 6 times 12 times K over 18K, 3, 4, where is a 4K. Now, if you're combining 6K and 3K, they are parallel together. 6K times 3K over 6K plus 3K, that is 2K. Now we have 2K and 2K, combining these two is a 2K. So 2K parallel with the 2K, that is 1K, right? 2K parallel to 2K, that is multiply for the numerator, add to the denominator, that is 4K over 4K equals 1K. So when we have a two same value resistors are parallel, you just need to cut it in half. So now it looks like this. So this 2 milliamp is actually going through here. That means plus minus 2 milli times 1K, which is 2 volts. And then here's the plus minus 8 volts. Then go back to one previous circuit. So this is plus minus 8 volts. This is plus minus 8 volts. And all of these parallel circuit, we know there's a plus minus 2 volts, plus minus 2 volts, plus minus 2 volts. Now let's go back to our circuit. We need to identify all those voltages across these resistors so that we can calculate the current. So we need to be careful with the polarity, and we said A is in this node, C is in this node, and then B is in this node. So let's find the 6K. Where is 6K? So 6K between C and B is right there. And the negative terminal towards to C, that means actual current going in this direction. And that is 8 over 6 milliamp. 3K, where is 3K? We have a 3K right there. Positive terminal towards to the A, therefore plus 2 volts minus. The actual current is going in that direction, and 2 over 3 milliamp. Now let's do KCL at the node K. Entering is only one entering, 2 over 3 milli equals leaving I sub A plus 4 over 3 milli. Therefore I sub A, we said I sub A2. I sub A2 is now 2 over 3 milli minus 4 over 3 milli, that is I sub A2 is now negative 2 over 3 milliamp. So based on the superposition theorem, we say I sub A equals I sub A1 plus I sub A2. I sub A1, that's what we found as negative 1 milli minus 2 over 3 milliamp. So I sub A is negative 5 over 3 milliamp.